Okay, let's get started. This is going to be problem number 63 on page 567 of the text. We have a mixture of water and alcohol, and they want us to find out about the vapor pressure. So we begin by noting that the temperature is 63.5 degrees, the pressure of the water is 175 torr, and the vapor pressure of the liquid of the alcohol at that temperature is 400 torr. It says they have equal masses. So an easy thing to do when you have equal masses is just to pick a number. So I'm going to pick 100 grams. If I have 100 grams of water, I know that the molar mass of water is 18.02 grams, and I know then that I'm going to have 100 divided by 18.02, and the answer is 5.55. So I have 5.55 moles of water if I have 100 grams. Doing the same thing with the alcohol, 100 grams of alcohol. You could choose any number. I'm just choosing 100. C2H6O. The molar mass of the alcohol is, well, shoot, it's 12.01 twice is 24.02. It's 6 H's, so that's 6.06, and it's 1 oxygen, which is 16. So that's 46.08. 46.08 grams per mole. So 100 divided by 46.08 is 2.17. C2H6O. Do you remember how to find mole fraction? Okay, mole fraction is the mole fraction of the alcohol is C2H6O. This is the first question. This is choice A. It tells us to find the mole fraction of the alcohol. The mole fraction of the alcohol means that we find the moles of the alcohol divided by the moles total. So remember, the moles total is these two. So I'm just going to write them both down here on the bottom. 5.55 plus 2.17. Okay? When I do that on the calculator, it's 2.17 divided by 7.73 rather. 7.73. And so that answer is 0.281. So the mole fraction of the alcohol is 0.281. The next question is to find the vapor pressure of the solution. So the vapor pressure of the solution is simply the sum of all the pressures that are pushing down on the solution. Okay, so again, you have maybe a mental picture of this, and if it's in a closed container, all right, the gas molecules are in here, and we're looking at the vapor pressure of what's pushing down on the surface of the water, okay, actually of the solution. So what's up here in the gas? Well, there's two gases. There is water vapor gas and there's alcohol gas. So both of these vapors are components of this. So how do we do this? We use Raoult's law. Remember that Raoult's law says the pressure of A is equal to the mole fraction of A times the pressure at the regular temperature, okay? So what we do is we're going to find the total pressure by adding these two numbers together. So the pressure of B, well, this will be the water vapor, is the mole fraction of B times the pressure. Okay, that's what these numbers up here are given to us for. So let's go ahead and start. I'll start with the water. So the pressure of the water is equal to the mole fraction of the water was 5.55. And the vapor pressure of water at that temperature is 175 torr, and so I just multiply 175 by 5.55. And so the vapor pressure of the water, 175 times 5.55. I'm sorry, I haven't found the vapor pressure of the water. The vapor pressure of the water is not 5.55. The vapor pressure of the water is 1 minus 0.281. Remember that the vapor pressures always add up to 1. So I have to find the vapor pressure of the water, and that number is 0.719. So this is 0.719 times the quantity 175 torr. Remember, that's the vapor pressure of water at 63.5 degrees. So this number turns out to be 125.8 torr. Okay? The vapor pressure of the alcohol above the surface of the water of the solution is going to be the mole fraction of the alcohol, 0.281, times its vapor pressure, which is 400. Now, did you notice that the vapor pressure of the alcohol is higher? That's because alcohol is more volatile. It has lower LDFs holding it together because it is a less polar substance than the water is. So 0.281 times 400 is 0.281 times 400, 112.4. Okay? And so 112.4 torr for that one. Then all we have to do is add these two numbers together. When we add these two numbers together, we have the answer to B, which is that the total pressure of the solution of all the things in the solution is 238 torr. Do you see how we got that? This component of the water produces this much pressure. This component of the alcohol produces this much pressure. Pressure that Dalton's law says pressure total is equal to pressure 1 plus pressure 2 plus pressure 3, etc., etc. Okay? The last one's the hardest one. It asks us to calculate the mole fraction of the ethanol in the solution. And so at first you think, wow, how am I going to do this? But let me remind you that gases and moles, if they're gases, can be thought of to be the same. A mole of gas produces a certain temperature, a certain pressure. You double the number of moles, you double the pressure. You triple the moles, you triple the pressure. You have it, you have it. So that's all we have to do. We just have to figure out the fraction of the pressure that the alcohol has. So just for the alcohol, because this is what the question is asking us, the mole fraction of the alcohol is going to be the pressure that the alcohol produces, which is 112.4 torr, divided by the total pressure of the whole system, which we just said was 238 torr. And so that number turns out to be 112 divided by 238. 0.472. 0.472 is the mole fraction of the gas of the alcohol vapor. And there you have it. That's the solution to number 63. Thank you.